There is a photograph taken in the winter of 1915 that almost no one has ever properly explained. It shows a wooden ship, three-masted, gripped on every side by ice, its hull tilted at an angle no vessel is ever supposed to sit at. The sails are gone. The rigging is coated white. And around it, in every direction, stretches a frozen ocean so vast and so silent that the men who were there described the quiet as a kind of pressure against the ears. What that photograph does not show is that the ice was slowly, patiently, crushing the ship to death. It would take 9 more months to finish the job. The men aboard already knew. They had heard it at night, the groaning of the timbers, a sound one of them compared to the moaning of a living thing in pain. They were more than 1,000 miles from the nearest human being, and no one on Earth knew where they were. That is where this begins. Not with a date, not with a definition, but with a question that has never fully gone away. Why does this place, the coldest, driest, highest, emptiest continent on the planet, keep pulling human beings toward it, decade after decade, when it offers them almost nothing but suffering in return? Antarctica has killed explorers, swallowed aircraft, hidden entire mountain ranges beneath its skin, and locked away secrets that we are only now, with satellites and radar and machines that can see through 2 miles of ice, beginning to uncover. And the strangest part is this: the more we learn about it, the less familiar it becomes. If you enjoy long, slow journeys like this one, the kind you can sink into as the night goes on, consider subscribing. There are many more of these ahead. Let me tell you what we actually know. And then let me tell you how much we do not. Antarctica is roughly the size of the United States and Mexico combined. It holds about 90% of all the ice on Earth, and inside that ice sits close to 70% of the planet's fresh water. If all of it melted, and it will not melt soon, but if it did, the world's oceans would rise by roughly 60 meters, nearly 200 feet, redrawing every coastline humanity has ever built upon. But here's the thing that surprises almost everyone the first time they hear it. Antarctica is a desert. It is, in fact, the largest desert on Earth. In the deep interior, some regions receive less moisture than the Sahara. The snow you imagine falling endlessly across those white plains is, in many places, snow that fell thousands of years ago and simply never went anywhere, because it is too cold for it to melt and too dry for much more to arrive. The cold itself is difficult to hold in the mind. On the 21st of July, 1983, at a Soviet research station called Vostok, sitting on top of nearly 4 kilometers of ice near the center of the continent, a thermometer recorded a temperature of minus 89.2 degrees Celsius. That is minus 128 degrees Fahrenheit. At that temperature, if you were to throw a cup of boiling water into the air, it would vanish into crystals before it touched the ground. Steel becomes brittle. Diesel fuel turns to jelly. Exposed skin freezes in less time than it takes to describe what is happening to it. And yet, decades later, satellites peering down at the high ridges of the East Antarctic Plateau measured surface temperatures even lower, approaching minus 98 Celsius. Temperatures so extreme that scientists initially wondered whether their instruments had made a mistake. They had not. There are places on this planet, right now, tonight, where the air is nearly cold enough to make you doubt that air can behave that way at all, and the cold does not sit still. It moves. There is a kind of wind in Antarctica found in few other places on Earth in such ferocity, called the katabatic wind, and understanding it explains a great deal about why this continent is so lethal. Because the interior of the continent is a high dome of ice, and because the air over that dome is chilled to extraordinary temperatures, that cold air, being dense and heavy, begins to slide downhill, drawn by gravity from the high center of the continent toward the coasts. As it descends, it gathers speed, and in places where the terrain funnels it, it accelerates into a screaming torrent of frigid air that can blast down toward the sea at speeds rivaling a hurricane. In gusts that have been recorded above 200 miles an hour. There are stretches of the Antarctic coast that are among the windiest places on the entire planet, where the katabatic wind pours down off the ice sheet almost without pause, day after day, driving snow before it in a blinding white fury. A wind so relentless that the early explorers who wintered in its path described it as a living enemy, a thing that never rested, that clawed at their huts and tried to tear them from the earth. To be caught outside in a full katabatic storm is to be plunged into a world of pure white chaos, unable to see a hand held before your face. The wind so loud you cannot hear your own shout. The cold driven straight through any clothing by the force of the moving air. This is what a blizzard truly is at the bottom of the world, and it is one of the great killers of the continent. The thing that pins expeditions in their tents for days and buries the unwary and turns a routine walk between two buildings into a fatal gamble. Stations string ropes between their buildings for exactly this reason, so that a person caught out when the wind rises can find their way back by feel alone, hand over hand, blind in the roaring white. Consider, too, the sheer physical scale of the place, which the mind resists holding all at once. The ice sheet in its thickest parts is nearly 3 miles deep, so heavy that it has pressed the very bedrock of the continent down into the earth, and so vast that if it were removed, the land beneath would slowly rise for thousands of years, rebounding from the weight it had carried. The continent is so large that a single one of its ice shelves, the great floating platforms of ice fringing the coast, can be the size of a major country. Distances that look small on a globe become, on the ground, journeys of weeks. And over all of it presides a silence and an emptiness that has no equal anywhere else on the surface of the earth. There are no cities, no roads to speak of, no farms, no forests, no rivers running to the sea in the ordinary way, no sound of human life across an area larger than the United States. It is the last true wilderness, the final place on the planet that human beings have never tamed and, by treaty and by its own ferocity, may never tame. But cold is only the beginning of what makes this continent strange. And it is not even the reason those men were trapped in the ice in 1915. To understand that, we have to go back a little, to an age when the map of the world still had a genuine blank space at the bottom of it. A space that drew a certain kind of person, the way a lit window draws a moth in the dark. For most of human history, Antarctica was a theory. The ancient Greeks, who reasoned that a great landmass must exist in the south to balance the lands they knew in the north, gave it a name long before anyone had seen it. They called it Antarcticos, the opposite of the Arctic, the region beneath the constellation of the Bear. It was a guess, an act of pure geometric imagination, and it turned out to be correct, though it would take more than 2,000 years for anyone to prove it. For a long time, the imagined southern land grew in the minds of mapmakers into something far grander than the reality would turn out to be. On the old charts, it was drawn as a lush and populous continent, Terra Australis Incognita, the unknown southern land, and it was believed to be fertile, temperate, perhaps even rich, a vast realm waiting to be claimed. Explorers were sent to find it, driven partly by geographic reasoning and partly by the dream of new lands and new wealth. and one by one they failed. They sailed south and found not a green and welcoming continent, but a wall of storm and ice, an ocean growing ever colder and more violent the further they pressed. Explorers sailed south for centuries and found only open water, storms, and the great belt of ocean that rings the continent, where waves can build without any land to break them, and winds circle the entire globe unopposed. Sailors came to fear those latitudes and gave them grim, poetic names. The roaring 40s, the furious 50s, the screaming 60s. To go south was to enter a world that seemed actively hostile to the idea of human passage. Captain James Cook, the great British navigator, crossed the Antarctic Circle in 1773, the first person known to have done so, and sailed through fog and ice for weeks. Convinced that land lay somewhere beyond the pack, he never saw it. He turned back at last, defeated not by cowardice, but by simple physics, and wrote that if anyone were to venture further than he had, he would not envy them the discovery, for the world would gain no benefit from it. He was wrong about the benefit, but he was right about the difficulty. It would be almost 50 more years before human eyes confirmed that the seventh continent was truly there. When the confirmation finally came, it came quietly, and it came surrounded by argument. 3 separate expeditions, Russian, British, and American, all approached the continent within a span of months around 1820. And to this day, people debate who saw the mainland first. A Russian expedition under Fabian von Bellingshausen sighted an ice shelf in January of that year. A British naval officer named Edward Bransfield charted land days later. An American sealer named Nathaniel Palmer, only 21 years old, hunting for fur seals in the southern waters, came upon the peninsula that same season. There was no flag planting ceremony, no triumphant announcement heard around the world. There were only cold men on small ships, glimpsing a white shape through the mist, unsure at first whether they were looking at cloud or iceberg or something more permanent. And in a way, that uncertainty has never fully left. Antarctica has always been a place where it is hard to be sure of what you are seeing. The men who came next came for money. The southern oceans, it turned out, were rich with life. Seals whose fur was worth a fortune, and later whales whose oil lit the lamps of the industrial world. For a few decades, the hunt was ferocious. Entire seal colonies were wiped out in a single season. The whalers followed, and they built stations on the islands ringing the continent, grim little settlements of rendering vats and rusting machinery, where the water in the harbors sometimes ran red. It was ugly, extractive work, and it left scars that are still visible today. But it also put ships and men into those waters year after year, and slowly, almost as a side effect, the shape of the coastline began to be drawn onto the map. Commerce did what curiosity alone had not. It brought human beings close enough to the continent that the next step, actually setting foot upon it and pushing inland, began to seem possible. That step, when it came, launched what later generations would call the heroic age of Antarctic exploration. And it produced some of the most extraordinary stories of endurance in the entire history of our species. These were not stories of easy triumph. Most of them were stories of suffering, and some of them were stories of death. But there is a quality to them, a strange nobility, that has kept them alive in our imagination for more than a century. They are stories about what human beings will endure, and what they will do for one another when they are pushed to the absolute limit of what a body and a mind can bear. Consider what these men were attempting. They were trying to travel on foot, hauling sledges loaded with hundreds of pounds of supplies across a continent no one had ever crossed. in temperatures that could freeze the fluid in a person's eyes, through storms that could pin them in a tent for a week, toward a goal, the South Pole, that was nothing more than a mathematical point on an empty plain of ice, indistinguishable from the ice all around it. There was no reward waiting there. No treasure, no city, no oasis. Just a spot where the lines on a chart converged, and the knowledge that you had stood somewhere no human had stood before. And men were willing to die for it. Many did. The race for the pole came to a head in the southern summer of 1911 and 1912, and it became one of the most famous and most tragic contests in the annals of exploration. On one side was a Norwegian named Roald Amundsen, a cold, meticulous professional who had spent his life learning the craft of polar travel, who studied how the Inuit of the Arctic survived, who used dogs and skis and traveled light and fast. On the other was a British naval officer named Robert Falcon Scott, brave, romantic, and burdened by a national expectation that the pole should be claimed for the Empire, who relied on a mixture of ponies, motor sledges, and ultimately the raw muscle of men hauling their own loads. The difference between the two men was, in the end, a difference of philosophy, and the ice judged them for it without mercy. Amundsen treated polar travel as a craft to be mastered, humbly, by learning from those who already knew it. He had lived among Arctic peoples and studied how they survived, how they dressed in furs rather than woven cloth, how they used dogs not merely to pull but, when necessary, as food, feeding the weaker animals to the stronger and to the men. A hard calculation that he had planned from the start. His clothing was loose and warm, his diet carefully considered, his route laid out with depots of supplies marked by lines of flags so that he could not miss them on the way back. Everything about his expedition was quiet, unglamorous, and ruthlessly effective. Scott, by contrast, carried the weight of an empire's expectations and a certain romantic idea of how such a thing ought to be done. By British pluck and endurance and the nobility of men hauling their own burdens, he distrusted dogs and relied instead on ponies, which were ill-suited to the ice, and on experimental motor sledges, which broke down. When the animals and machines failed, as they did, his men were left to drag their heavy sledges themselves, mile after exhausting mile, burning far more energy than they could replace from their rations. It was brave. It was also, in the cold light of the outcome, a fatal way to travel. Amundsen reached the South Pole on the 14th of December, 1911. He found it, took his measurements, planted his flag, and turned for home, and every man in his party survived. He had made it look almost easy, which it was not, and which was precisely the point, because he had done the difficult, invisible work of preparation so thoroughly that the journey itself held few surprises. He would say later that adventure was merely a sign of poor planning, that the true explorer's aim was to encounter nothing he had not foreseen. It was a cold and unsentimental view, and it kept his men alive. Scott reached the same spot 34 days later, in January of 1912, and what he found there broke something in him. There, on that white nothing at the bottom of the world, fluttering in the wind, was the Norwegian flag. Amundsen had beaten him. Scott wrote in his diary that the place was terrible, that all the daydreams had to go, that they now faced 800 miles of weary trudging, back with nothing to look forward to, and the trudging back killed them. One by one, on the return journey, Scott's men fell. One walked out of the tent into a blizzard and never returned, sacrificing himself because he believed his frostbitten condition was slowing the others down. And his last recorded words have echoed through the centuries since. He said he was just going outside, it might be some time. Scott himself and his 2 remaining companions died in their tent, pinned by a storm, only 11 miles from a supply depot that would have saved them. His final diary entries are almost unbearable to read. They were found 8 months later, frozen, along with the letters he had written to the families of his men and to his own wife, and along with something else that tells you a great deal about the men of that age. Even at the end, dying, starving, they had refused to abandon 35 pounds of rock samples they had collected, geological specimens they believed were too scientifically valuable to leave behind. They dragged that stone to their graves, and they were right too. Those rocks contained fossils that would later help prove one of the great ideas in the history of science. But I am getting ahead of the story. Let me pause on those rocks for a moment, because they lead somewhere astonishing. And they are a good example of how the smallest thing carried out of Antarctica can overturn the largest ideas about our world. Among the fossils and the specimens Scott's party dragged to their deaths were the impressions of an ancient plant called Glossopteris, a fern-like tree that once grew in warm, swampy forests. Forests in Antarctica. The presence of that plant, frozen into rock at the bottom of the world, was a piece of evidence that helped, over the following decades, to prove one of the most revolutionary ideas in the history of science. The idea that the continents themselves move, drifting across the face of the planet over unimaginable spans of time. Because the very same fossil plant, Glossopteris, was found not only in Antarctica, but in South America, in Africa, in India, in Australia, scattered across land masses now separated by entire oceans. How could an identical plant have grown on continents thousands of miles apart, across seas its seeds could never have crossed? The answer, once it was accepted, was staggering. The continents had once been joined, all of them. There had been a single, enormous supercontinent, which scientists named Pangaea, and later a great southern landmass called Gondwana. And Antarctica had sat at the very heart of it, not frozen at all, but green and warm, clothed in forests, home to rivers and swamps and living things. Antarctica was once a jungle. Dinosaurs walked upon it. It has yielded the fossilized bones of ancient reptiles and amphibians, of creatures that could only have lived in a temperate or even subtropical climate. The frozen continent at the bottom of the world was, in the deep past, a place of green valleys and running water. And then, over millions of years, the slow drift of the continents carried it south, to the very axis of the planet, where the cold closed in and the ice came down and buried everything, sealing that lost green world beneath the white. The men who died dragging those rocks did not know all of this, but they knew the specimens mattered, and they were right. And it is difficult to think of a more poignant example of the human hunger for knowledge than 3 dying men refusing to lighten their load by even a single stone that science might one day need. The transformation of that lost green world into the frozen one we know did not happen quickly. And the way it happened is a story worth telling, because it reveals how delicately balanced the whole system is. For a very long time, even after Antarctica had drifted to its position over the South Pole, it was not covered in ice. It was cold, certainly, but it remained connected to the other southern continents, to South America and Australia. And warm ocean currents from the tropics could still reach its shores and keep it from freezing over entirely. Then, roughly 34 million years ago, the geography of the planet shifted in a way that sealed the continent's fate. The last land bridges connecting Antarctica to its neighbors broke apart. South America pulled away, opening a passage of deep ocean and Australia drifted north. And for the first time, the sea could flow freely all the way around the continent, unobstructed by any land, driven by the relentless westerly winds. A new ocean current was born, the Antarctic Circumpolar Current, the mightiest current on Earth, a river of cold water encircling the entire continent, moving more water than all the rivers of the world combined many times over. And this circling current did something profound. It walled Antarctica off from the warmth of the rest of the planet, like a moat of cold water around a fortress, preventing the warm tropical waters from ever reaching its shores again. Isolated behind that barrier, cut off from the warmth of the world, Antarctica grew colder and colder, and the ice began to form, and to spread, and to thicken, year upon year, century upon century, until the whole continent lay buried beneath the white sheet we know today. It was the birth of the frozen Antarctica, and it happened because a few narrow bridges of land, thousands of miles away, quietly slipped beneath the sea. The whole climate of the planet turned on it. That same circling current still flows today, still isolating the continent, still keeping it frozen. And it is one of the great governing forces of the Earth's climate, mixing the waters of the world's oceans and driving currents that reach to the far side of the globe. The frozen Antarctica is not a permanent feature of the Earth. It is a chapter with a beginning we can date, and its existence depends on an arrangement of continents and currents that has held for 34 million years, but that will not hold forever. That is the deep truth this continent teaches over and over to anyone who studies it long enough. Nothing here is as fixed as it looks. The ice that seems eternal came into being at a moment we can name, and it will one day end. The green forests that seem impossible were real, and their fossils prove it. The land beneath the ice, which seems dead and buried forever, is slowly moving, slowly rebounding, riddled with hidden fire and hidden water. Even the position of the continent itself has changed across the ages and will change again, over spans of time so vast that they reduce the whole of human history to a single held breath. What makes Scott's death haunting is not just the tragedy of it, but the nearness of the escape. 11 miles. In good weather, a single day's walk. The margin between survival and death in Antarctica has always been that thin, and it remains that thin today, even with modern gear and satellite phones and aircraft on standby. The continent does not forgive small errors. It rarely gives second chances, and that unforgiving quality is precisely what draws certain people to it, then and now. But the story I began with, the ship in the ice, is not Scott's, and it is not Amundsen's. It belongs to a man named Ernest Shackleton, and it is, to my mind, the greatest survival story ever told, precisely because it is a story in which the grand goal fails completely, and yet not a single life is lost. Shackleton had already been to Antarctica. He had come within 97 miles of the South Pole on an earlier expedition and turned back, choosing to save his men rather than risk everything for the final push. A decision that took more courage than reaching the pole would have. When Amundsen and Scott claimed the pole itself, Shackleton set his sights on the one great prize that remained. He would cross the entire continent, coast to coast, on foot, passing through the pole along the way. He called it the Imperial Trans-Antarctic Expedition. His ship was named, with an almost unbearable irony given what was to come, the Endurance. The Shackleton family motto, from which the name was taken, was simple: by endurance we conquer. They never reached the continent. In January of 1915, still a day's sail from the coast where they meant to land, the Endurance became trapped in the pack ice of the Weddell Sea. The ice closed around the hull and held it fast, and there was nothing to be done but wait and hope that when the ice broke up in the spring, the ship would float free. It did not float free. For 10 months the ship drifted, locked in the ice, carried helplessly wherever the frozen ocean chose to take it, more than 1,000 miles from any hope of rescue. And then, slowly, the ice began to squeeze. The pressure built until the ship's timbers, thick oak beams built specifically to withstand ice, began to bend and splinter. The men worked the pumps around the clock. It was hopeless. In late October, Shackleton gave the order to abandon ship, and they dragged what they could out onto the ice and watched their vessel die. On the 21st of November, 1915, the Endurance finally slipped beneath the ice and was gone. Shackleton wrote a single line in his diary: "She's gone, boys." Now consider their situation, because it is almost impossible to overstate how hopeless it was. 28 men, stranded on a slab of drifting sea ice in the most remote ocean on Earth. No ship, no radio contact with the outside world, no possibility of rescue because no one knew where they were, and no one would come looking in a place no rescue vessel could reach. They had a few small lifeboats they had salvaged, some tents, some supplies, and the dogs. That was all. Between them and any human settlement lay hundreds of miles of shifting ice and storm-racked ocean. By every reasonable calculation, all 28 of them should have died. They camped on the ice for months, waiting as their frozen raft drifted slowly northward and began, at last, to break apart beneath them. When the floe finally cracked and could no longer hold them, they launched the 3 small lifeboats into the open sea and made for the nearest land, a bleak, uninhabited spit of rock called Elephant Island. The crossing took days of soaked, freezing, sleepless misery, the men bailing constantly, hallucinating from exhaustion and thirst. They reached Elephant Island, and for the first time in 16 months, they stood on solid ground. But solid ground was not salvation. Elephant Island was a place no ship ever visited. A barren rock lashed by storms, offering nothing but a slightly less certain form of death than the ice had. They could not stay there and live. And so Shackleton made a decision so audacious, it still seems like madness. He would take one of the lifeboats, a small open boat barely more than 20 feet long, and with 5 men, he would sail it across 800 miles of the most violent ocean on the planet, the Southern Ocean in winter, to reach a whaling station on an island called South Georgia, 800 miles, in an open boat, through seas where waves could rise as high as a building in a part of the world where the wind never stops. If they missed the island, even by a little, there was nothing beyond it but thousands of miles of empty water, and they would sail on until they died. Navigation would depend on brief glimpses of the sun through the clouds, taken with a sextant on a pitching deck with wet hands and numb fingers. A single significant error, and they would all be lost, and the men left behind on Elephant Island would be lost with them. They set out in late April. What followed was 17 days of an ordeal that the men who survived it could barely describe afterward. The boat, the James Caird, was constantly awash. Ice formed on the hull and had to be chipped away before its weight capsized them. The men were soaked through, frostbitten, their clothes never drying, sleeping in shifts in a space too cramped to stretch out in. At one point, a wave struck them so enormous that Shackleton, seeing a line of white on the horizon, mistook it for a break in the clouds, until he realized it was the crest of a single wave, larger than any he had seen in 26 years at sea. It nearly ended them, but it did not. And after 17 days, by a feat of navigation that experts still regard as almost miraculous, they sighted the black cliffs of South Georgia rising out of the sea. Even then, the ordeal was not over. And the final chapter is perhaps the most astonishing of all. They had reached South Georgia, but they had made landfall on the wrong side of the island, the uninhabited side. The whaling station lay on the far coast, and between the two lay a mountain range, glaciers and peaks that no human being had ever crossed, terrain so forbidding that it would not be traversed again for decades. And when it finally was, it was by trained mountaineers with modern equipment. Shackleton had 3 exhausted, half-starved men, no map, no climbing gear, and a length of rope. He took 2 of the strongest and left the others behind. And the 3 of them walked for 36 hours straight, without rest, across those uncharted mountains. At one point, trapped on a ridge as darkness and cold closed in, facing a slope too steep to climb down safely, Shackleton made another impossible decision. They coiled their rope into 3 small seats, sat upon it, and slid down the mountainside into the blackness, not knowing what lay below. Whether a gentle slope or a cliff edge or a chasm, it was, by any measure, an insane thing to do. It worked. They walked into the whaling station at Stromness, looking like creatures out of a nightmare, black with grime and blubber smoke, their hair and beards matted, their clothes in rags. The first people to see them were 2 children who ran away in fright. The station manager, a man who had known Shackleton before the expedition, did not recognize him. Shackleton asked quietly when the war would be over, for they had sailed south before the First World War began and had heard nothing of the world for nearly 2 years. The answer he received was that the war was not over, that millions had died, that the world he had left had become a slaughterhouse. He had returned from one nightmare into another. But here is what matters. The thing that makes this story different from Scott's, from all the others. Shackleton went back. It took him 3 more months and 4 separate attempts, beaten back each time by ice. But he refused to leave his men on Elephant Island to die. On the 30th of August, 1916, more than 4 months after he had sailed away in the James Caird, he returned to that barren rock and found all 22 men still alive, having survived the winter beneath 2 upturned lifeboats, eating seals and penguins, keeping a lookout every single day for the ship they were not sure would ever come. When they saw him approaching, they cheered. Every one of the 28 men who had sailed on the Endurance came home alive. The expedition had failed utterly at its stated goal, and it became immortal anyway. I have spent a long time on this story, and I have done so deliberately, because it captures something about Antarctica that no list of facts and figures ever could. This is a place that reduces human beings to their essence, that strips away everything comfortable and false, and leaves only the core of who they are. And when you look at that core, at what people like Shackleton and his men actually did, you find something that is almost impossible to believe. And yet it happened. And there are photographs to prove it, taken by a man named Frank Hurley, who hauled his heavy glass photographic plates across the ice, and even dove into the freezing, flooded, sinking ship to rescue his negatives, because he understood, correctly, that the world would need to see this to believe it. Not every story from that age ended with survival. And the continent has a way of swallowing people whole, of taking them and never giving them back. There was an Australian expedition led by a scientist named Douglas Mawson, running at almost exactly the same time as Scott's fatal march. And what happened to Mawson is one of the most harrowing tales of survival ever recorded. A story that somehow remains far less known than it deserves to be. Mawson set out across the ice with two companions, a young British soldier and a Swiss mountaineer, and 3 sledges pulled by dog teams to explore an unmapped region of the coast. Hundreds of miles from base, disaster struck without warning. The soldier, walking behind, along with the sledge carrying most of the food, the tent, and the best of the dogs, vanished. He had walked over a hidden crevasse, a deep crack in the ice, bridged by a thin skin of snow, and the snow had given way. He fell into the blue depths of the glacier and was gone, instantly, without a sound anyone could recall, taking with him almost all of the supplies the survivors needed to live. Mawson and the Swiss mountaineer were left more than 300 miles from safety, with almost no food, no tent, and a handful of dogs. What followed was a nightmare journey back across the ice. They were forced to eat the dogs, one by one, as the animals gave out. And in their starvation, they ate everything, including the livers, not knowing that the liver of a sled dog contains a concentration of vitamin A so high that it is poisonous to human beings. Both men grew horribly sick. The mountaineer deteriorated, his mind and body failing. And partway through the return, he died in his sleeping bag, leaving Mawson entirely alone, hundreds of miles from base, starving, poisoned, the soles of his feet detaching from the flesh beneath so that he had to bind them back on and walk on them anyway. And still, alone, he kept going. At one point, he fell into a crevasse himself, saved only by the rope tying him to his sledge, and hung there in the void, unable to climb the rope with his ruined body, and made peace with dying, and then somehow found the strength to climb out anyway. He walked back to base entirely alone, a skeleton of a man, and reached it only to see his rescue ship sailing away over the horizon, hours too late, condemning him to another full year on the ice before another ship could come. And even that he survived. Douglas Mawson lived and grew old and died in his bed decades later. But the continent had shown him exactly what it was capable of, and he never forgot. The ice takes people and holds them, somewhere in the frozen depths. The body of that young soldier still lies where he fell, perfectly preserved in the blue ice, being carried slowly over centuries toward the coast. And one day, perhaps thousands of years from now, the moving glacier may deliver him back to the surface at the sea's edge, unchanged, exactly as he was on the day he vanished. This is not fantasy. It has happened. The bodies of people lost on the ice have emerged from glaciers decades later, carried down and out by the patient flow of the ice. And in some cases, the ice sheet itself has been calculated to be slowly delivering the lost expedition members of a century ago back toward the coast, on a journey that will take many more centuries to complete. Even the aircraft that Antarctica has swallowed sometimes come back. There is a story of a plane that crashed and was lost in the snow and was rediscovered decades later, entombed but intact, gradually being carried by the ice toward the day it too will reach the sea. The continent keeps what it takes, but it does not always keep it forever. It simply keeps it on a time scale that has nothing to do with human patience. And yet, for all the human drama, the men of the heroic age barely scratched the surface of what Antarctica actually is. They crossed its edges. They suffered on its coastal ice. But beneath their feet, and beneath the pole itself, lay a world they could not even have imagined. A world we are still, more than a century later, only beginning to map. Because the ice that nearly killed all of them is not the whole story. It is not even most of the story. The ice is a lid. And the question that has come to obsess modern science is a simple one. What exactly is underneath it? For most of the 20th century, no one could answer that question. because there was no way to see through 2 miles of solid ice. You could stand on the surface and have no idea whether you were standing above solid rock, or above a hidden mountain, or above a lake, or above nothing at all. The interior of the continent was, in the most literal sense, a sealed box. And then, gradually, we learned to see through it. And what we found rewrote our understanding of the place entirely. The first great surprise came from a technology developed for a very different purpose. In the years after the Second World War, aircraft carried radar, and pilots flying over Antarctica noticed something troubling. Their radar altimeters, which bounced radio waves off the surface below to measure altitude, were giving strange, inconsistent readings over the ice. It turned out that radio waves, unlike visible light, can pass straight through ice and were bouncing off the rock far below and confusing the instruments. To the pilots, this was a hazard. To scientists, it was a revelation. If radio waves could travel through ice and bounce off whatever lay beneath, then you could use them to map the hidden landscape, to peel back the ice electronically and draw the shape of the buried world. This technique, radio echo sounding, became one of the most powerful tools in all of Earth science. Aircraft began flying long, patient survey lines back and forth across the continent, firing radio pulses down into the ice and listening for the echoes. And slowly, line by line, a hidden Antarctica began to emerge. What that hidden Antarctica looks like is astonishing. Beneath the smooth white surface lies a landscape of staggering drama. Entire mountain ranges as large as the Alps, buried completely, never touched by sunlight, never seen by any eye. Deep valleys, vast plains, and in places, the rock beneath the ice plunges far below sea level, scoured out by the weight of the ice into basins thousands of feet deep. There is a mountain range near the center of East Antarctica called the Gamburtseff Mountains, and it is one of the strangest features on our planet. It is a range roughly the size of the European Alps, with sharp peaks and deep valleys, and it is completely entombed in ice. And here is the mystery. No one is entirely sure how it got there. Mountain ranges are usually built when tectonic plates collide, and that collision leaves geological fingerprints, evidence of the crash. But the center of East Antarctica has been geologically quiet for hundreds of millions of years. There has been no recent collision. And yet these mountains have sharp, youthful-looking peaks, the kind you would expect on a young range, not one worn down over eons. How can an ancient, stable region contain a range that looks freshly made? Scientists have theories involving ancient rifting and the strange way ice can preserve a landscape by protecting it from erosion. But the honest answer is that the Gamburtseff Mountains are not fully understood. There is a mountain range at the heart of a continent, and we do not entirely know why it exists. There is fire beneath this ice too, which is perhaps the last thing anyone expects to find at the bottom of the world. Antarctica is home to volcanoes, some of them active, and one of them is among the strangest mountains on the planet. It is called Mount Erebus, and it rises more than 12,000 feet directly out of the ice near the coast. And at its summit, in the crater, sits something almost unbelievable in that frozen landscape. A lake of molten lava, one of only a handful of permanent lava lakes on Earth, bubbling and churning in the open air, sending up plumes of steam and gas, and occasionally hurling out globs of molten rock in the middle of the coldest continent on the planet. Fire and ice, side by side, at the very edge of the world. The early explorers named the mountain after one of their ships, which in turn had been named for the ancient Greek god of darkness, a fitting name for a mountain of fire at the bottom of the world. Around the mountain's flanks, the volcanic heat escaping through the ground melts caves and chimneys into the surrounding ice, creating a hidden network of warm caverns of glowing blue ice beneath the snow, sheltered from the wind, warmed from below. And scientists exploring these caves have found them lined with delicate ice crystals, and warm enough, in places, to harbor unusual microbial life found nowhere else. A warm, living cave inside a frozen mountain of fire in the coldest place on Earth. And there are other volcanoes, dozens of them, most hidden entirely beneath the ice sheet, discovered only by the radar surveys. And no one is quite certain how many more remain undetected. Some of that buried volcanic heat may be part of what keeps the hidden lakes from freezing, and part of what could, in some places, quietly weaken the ice from below. A continent we imagine as a dead white expanse turns out to have a beating volcanic heart, half hidden, only partly understood. The radar revealed something else, something that seems almost impossible in the coldest place on Earth. Water, liquid water, not on the surface, where it could never survive, but deep beneath the ice, at the very bottom, where the ice meets the rock. In the 1960s and 70s, as the radar surveys accumulated, scientists began to notice strange, flat, mirror-like reflections coming back from the base of the ice sheet in certain places. A flat reflection means a flat surface. And the flattest surface in nature is the surface of a body of still water. They were detecting lakes. Lakes of liquid water, sealed beneath 2 miles of ice, in the heart of a continent where the air can freeze mercury. How is that possible? 2 things conspire to make it so. First, the immense weight of the ice above, pressing down with tremendous force, lowers the melting point of ice at the base, just as pressure lowers the temperature at which water freezes. Second, and more importantly, the Earth itself is warm. Deep beneath our feet, everywhere on the planet, heat flows slowly upward from the planet's interior. This geothermal heat is normally lost to the atmosphere. But under Antarctica, the 2-mile-thick ice sheet acts as a colossal insulating blanket, trapping that warmth against the base. Caught between the Earth's internal heat below and the crushing, insulating ice above, the very bottom of the ice sheet, in many places, melts, and the melt water collects in the hollows of that hidden landscape, forming lakes. The largest of these is called Lake Vostok, and it lies beneath that same Russian station where the coldest temperature on Earth was recorded, which is a fact almost too strange to be true. Directly below the coldest place ever measured on the surface of our world, sealed under nearly 4 kilometers of ice, lies a lake of liquid water roughly the size of Lake Ontario. It is about 250 kilometers long. In places, it is more than 800 meters deep. And it has been sealed off from the surface, from the atmosphere, from sunlight, from the rest of the biosphere, for something on the order of 15 million years. 15 million years. To put that in perspective, our own species, in anything like its modern form, has existed for perhaps 300,000 years. When Lake Vostok was last in contact with the open air, there were no human beings, no early humans of any kind. The world was a fundamentally different place. And then the ice came down like a lid over a jar, and the lake was sealed. And it has been sitting there in absolute darkness, in absolute isolation, ever since. The obvious question, the one that gripped scientists the moment they understood what they were dealing with, was whether anything could be alive in there. It seemed impossible. A body of water cut off from sunlight and from the surface world for 15 million years, with no source of energy from the sun, under crushing pressure, in perpetual cold and dark. What could possibly survive that? And yet, we have learned in recent decades that life is far more stubborn, far more inventive than we ever imagined. We have found microbes living in boiling volcanic vents at the bottom of the ocean, in acidic pools, in the cores of nuclear reactors, deep inside solid rock, miles beneath the Earth's surface, feeding not on sunlight, but on chemistry, on the raw energy locked in minerals and gases. If life can survive in those places, why not in a hidden Antarctic lake? The desire to find out led to one of the most delicate and controversial scientific undertakings of our time. To sample Lake Vostok, you would have to drill down through nearly 4 kilometers of ice. And the moment you broke through into the lake, you would risk contaminating a pristine, ancient, sealed environment with surface microbes and drilling fluid, potentially destroying the very thing you came to study, and doing so in a place that had been untouched for 15 million years.
The ethical weight of that was enormous. After years of painstaking work in 2012, a Russian team finally drilled down and reached the surface of the lake. The results were tangled and disputed, complicated by contamination from the drilling fluid, and the question of what truly lives in Lake Vostok, if anything, remains genuinely open. But other subglacial lakes, sampled more cleanly with more careful methods, have given a clearer answer. In a lake called Willans, and later in a lake called Mercer, drilled through with sterilized equipment, scientists found life. Not much of it, and nothing you could see with the naked eye, but real living communities of microbes. Thousands of distinct types, thriving in the cold and the dark, feeding on the chemistry of ancient rock, in water that had not seen the sun in a time beyond human comprehension. This matters far beyond Antarctica, and here is why. If life can persist in a place like that, isolated and lightless and frozen for millions of years, then the possibilities for life elsewhere in the solar system suddenly look much brighter, because there are other worlds with ice-covered oceans. Jupiter's moon Europa is believed to hide a vast ocean of liquid salt water beneath a shell of ice, an ocean that may contain more water than all the oceans of Earth combined. Saturn's moon. Enceladus is actively spraying water from a hidden sea out into space through cracks in its icy surface, geysers of ocean water shooting into the void. These are precisely the kinds of environments that the subglacial lakes of Antarctica help us understand. When scientists want to know how to search for life beneath the ice of a distant moon, and how to do it without contaminating what they find, they come to Antarctica to learn. The frozen continent has become, in a very real sense, a rehearsal stage for the search for life beyond our own planet. The lakes beneath the ice are a preview of worlds we may not reach for generations. And the ice itself, quite apart from what lies beneath it, turned out to be one of the most valuable scientific archives on Earth. A library written in frozen water, holding a record of the planet's past more detailed and more reliable than almost any other. To understand why, you have to understand how the ice sheet is built. Every year snow falls on the surface of Antarctica, and because it never fully melts, each year's snowfall is buried by the next, and the next, and the next, compressed over time into solid ice. The ice at the surface is fresh this year's snow. Go down a little and you are in last year's snow, and the year before that. Go down deeper and you are moving back through the centuries, and then the millennia. Near the very bottom of the deepest ice in some places, you are touching snow that fell more than 800,000 years ago, and there are older, more compressed layers that scientists believe may reach back well beyond 1 million years. Now here is the beautiful part. When that ancient snow was falling and being compressed, it trapped tiny bubbles of air, actual samples of the atmosphere from the moment that snow fell. Which means that when scientists drill down and pull up a long cylinder of ancient ice, an ice core, they are pulling up a physical timeline of Earth's atmosphere. Crack open a bubble from ice that fell 400,000 years ago, and you are breathing, in a sense, air from a world 400,000 years gone. You can measure exactly how much carbon dioxide it contained, exactly how much methane, and by analyzing the chemistry of the ice itself, you can determine what the temperature was in the year that snow fell. Layer by layer, bubble by bubble, the ice cores let us read the climate history of the entire planet, going back nearly 1 million years, in extraordinary detail. And what those ice cores revealed changed our understanding of the world we live in. They showed that Earth's climate has swung over hundreds of thousands of years through great cycles of ice ages and warm periods, driven by subtle variations in the planet's orbit and the tilt of its axis. They showed that carbon dioxide and temperature have marched together through all of that history, rising and falling in lockstep, an intimate coupling written unmistakably in the ice. And they showed something that stopped scientists cold. For the entire 800,000-year record, through all those cycles, the amount of carbon dioxide in the atmosphere stayed within a certain range. It went up during warm periods and down during ice ages, but it never, in all that time, exceeded a certain ceiling. Until now. The level of carbon dioxide in our atmosphere today is far higher than at any point in that entire 800,000-year record, higher than the ice has ever seen. The frozen archive of Antarctica contains no precedent for the world we have made. That is not a matter of opinion or projection. It is simply what is frozen in the ice, a fact preserved in bubbles of ancient air, waiting patiently for us to drill down and read it. Antarctica has warned us before, and we listened, and it may be the single best example we have of humanity noticing a danger in time and actually doing something about it. In the 1980s, a small team of British scientists working at a remote Antarctic station noticed something alarming in their measurements of the atmosphere overhead. The layer of ozone high in the stratosphere, the invisible shield that protects all life on Earth from the sun's most dangerous ultraviolet radiation, was disappearing over Antarctica each spring, thinning so dramatically that a vast hole was opening in it, larger than the continent itself. At first they could hardly believe their own data, and checked and rechecked it, thinking their instruments must be failing, because the loss was so severe that no one had predicted anything like it. But the instruments were right. There was a hole in the sky over Antarctica, and it was growing. The cause, once it was understood, lay in certain man-made chemicals, chlorofluorocarbons, that had been used for decades in refrigerators and aerosol cans and countless industrial processes, drifting up into the high atmosphere where the unique frigid conditions over the Antarctic winter turned them into engines of ozone destruction. It was a genuine planetary emergency, an invisible wound in the atmosphere that threatened to expose living things across the southern hemisphere and beyond to a flood of harmful radiation. And here is the remarkable part. The world acted. Faced with clear evidence of a global danger, the nations of the Earth came together and agreed with unusual speed to phase out the chemicals responsible in an agreement now regarded as the most successful environmental treaty ever enacted. The production of those chemicals was banned. And slowly, over the decades since, the ozone layer over Antarctica has begun at last to heal. It is not fully recovered, and it will take most of this century to close entirely. But the trend has turned, and the hole is shrinking. It stands as one of the few unambiguous success stories in our troubled relationship with the planet. A case where a warning was heeded and a catastrophe was averted, and it began with a handful of people at the bottom of the world, staring in disbelief at a set of numbers that told them the sky itself was breaking. There is a project underway now, in these very years, to drill even deeper and further back, to recover ice that is more than 1.5 million years old, to read a chapter of Earth's history that the existing cores cannot reach. The teams working on it are drilling in some of the most remote and inhospitable locations on the continent, living for months in tents and prefabricated huts on the high polar plateau, in cold that would kill an unprotected person in minutes, all to pull up cylinders of ancient ice and carry the frozen past back into the light. It is slow, patient, unglamorous work, and it may tell us things about our planet's future that we very much need to know. But let us come back up, out of the deep ice and the hidden lakes, to the surface, to the living world. Because for all its lethal cold, Antarctica is not lifeless. Far from it. The waters around the continent are among the richest on Earth, and the story of how life clings on at the bottom of the world is, in its own way, as remarkable as anything buried in the ice. The foundation of all of it is a small shrimp-like creature called krill. Antarctic krill are only a few centimeters long, but they gather in swarms so vast that they are among the largest aggregations of animal life on the entire planet. A single swarm can stretch for miles and contain trillions of individuals, so dense that the water turns pink and the swarm can be seen from space. The total mass of Antarctic krill is thought to rival or exceed the total mass of all human beings on Earth. These tiny creatures feed on the microscopic algae that bloom in the sunlit surface waters and beneath the sea ice, and in turn, nearly everything else in the Southern Ocean feeds, directly or indirectly, on the krill. They are the foundation of the entire food web, the single thread from which almost all Antarctic life hangs. Whales, seals, penguins, fish, seabirds, all of them ultimately depend on those swarms of tiny creatures. It is a staggering thing to consider that the largest animals ever to exist on Earth, the great whales, are sustained by some of the smallest. And the whales came back to those waters after we very nearly wiped them out. The blue whale, the largest animal that has ever lived, larger than any dinosaur, with a heart the size of a small car and a call louder than a jet engine, was hunted in the Southern Ocean to the edge of extinction in the 20th century. Hundreds of thousands were killed. By the time hunting them was banned, the Antarctic blue whale population had been reduced to perhaps a few hundred individuals, a species pushed to the very brink. And yet slowly, over decades, in the protected waters around the continent, they have begun to return. Not to their former numbers, not yet, perhaps not for centuries. But scientists working in the Southern Ocean today are once again hearing the deep, low calls of blue whales, and once again seeing them surface and blow in waters where they had almost completely vanished. It is one of the few genuinely hopeful stories in the modern history of that ocean, evidence that even catastrophic damage is not always permanent, that given enough protection and enough time, life can find its way back. The ice that surrounds the continent is a world of its own, and it moves and breathes with the seasons in a rhythm that is one of the largest recurring events on the surface of the planet, though almost no one ever sees it. Each winter, as the cold deepens, the surface of the ocean around Antarctica freezes, and the continent effectively doubles in size, wrapped in a growing skirt of sea ice that, at its maximum extent, covers an area larger than the continent itself. Then each summer, most of that sea ice melts away again. This vast annual breathing of ice, expanding and contracting across millions of square miles, is one of the great engines of the planet's climate and ocean circulation, and it is monitored anxiously now by satellites, because in recent years the pattern has begun to behave in ways that break with everything we thought we knew, with the sea ice in some seasons dropping to levels far below anything recorded before, a change that scientists are still struggling to fully explain. And from the edge of the continent, from the great floating shelves of ice that spill off the land and out over the sea, are born the icebergs, and Antarctic icebergs are unlike anything else on Earth. These are not the modest, jagged bergs of the northern seas. When a piece breaks off or calves from an Antarctic ice shelf, it can be a slab of staggering dimensions, a flat-topped island of ice the size of a city or a small country. One iceberg that broke away in recent times was larger than some entire nations, a floating tabletop of ice covering thousands of square miles, so vast it was given a name and tracked for years as it drifted slowly through the Southern Ocean, threatening shipping lanes and wildlife colonies as it went, slowly melting, slowly breaking apart, releasing in its final years a flood of fresh water and ancient nutrients into the sea. These giant bergs can drift for years, even a decade, carried by the currents, and as they melt, they release into the ocean the mineral dust locked in the ice, fertilizing blooms of life in their wake, so that even in dying they feed the sea. To stand beside one of these bergs, dwarfed by a wall of ice hundreds of feet high and miles long, glowing with an inner blue light where the ancient compressed ice has squeezed out every bubble of air, is to understand, in the body, and not just the mind, the scale of the forces at work at the bottom of the world. On the ice itself, the most famous residents are the penguins, and the emperor penguin in particular does something so extraordinary that it seems almost like an act of deliberate defiance against the laws of survival. Emperor penguins are the only creatures that choose to breed during the Antarctic winter, in the coldest, darkest, most brutal conditions on the face of the Earth. As the last of the autumn light fades and the temperature plunges toward -60, the emperors gather on the sea ice, having walked for miles from the open ocean to reach their traditional breeding grounds. The female lays a single precious egg, and then remarkably she leaves, She transfers the egg to the male, balancing it carefully on his feet beneath a fold of warm skin, and she departs, walking back across the miles of ice to the sea to feed, leaving the male to guard their unborn chick. What the male emperor penguin then endures is almost beyond belief. For roughly 2 months through the depths of the Antarctic winter, in darkness and howling wind and cold that no other warm-blooded animal could survive, he stands there, holding the egg on his feet, eating nothing at all. He does not leave. He cannot leave, or the egg will freeze in seconds. He simply stands and endures through blizzards that can last for days, in temperatures that would kill him within hours if he were not doing something extraordinary. The males huddle together, thousands of them, packed tightly into a dense mass, and they take turns. The birds on the freezing outer edge of the huddle slowly shuffle inward, toward the warmth, while those in the warm center rotate outward to take their turn in the cold. It is a system of shared sacrifice, a rotating shield of bodies against the storm, and it is the only reason any of them survive. By the time the females return from the sea, fat with food, the males have lost nearly half their body weight and have been fasting in the cold for months. If the timing is off, if the female is late, the male may be forced to abandon the chick to save his own life. But usually the timing holds. The females return. The exhausted males finally walk back to the sea to eat. And a new generation of the toughest birds on Earth begins its life on the ice. There is a fish in those waters that solves the problem of the cold in a way so elegant it borders on the miraculous. The Southern Ocean is cold enough that its water sits below the normal freezing point of blood. By all rights, the fish that live there should freeze solid. Their blood should turn to ice in their veins. And yet they swim freely, thriving in water that should kill them. How? Over millions of years, these fish, called ice fish and their relatives, evolved a kind of natural anti-freeze, special proteins in their blood that latch onto the tiny ice crystals that begin to form and prevent them from growing, stopping the freezing process before it can take hold. It is one of the most remarkable evolutionary adaptations ever discovered, and it is being studied intensely, because the ability to prevent ice crystals from forming has enormous potential value, from preserving transplant organs to improving frozen foods. Some of these fish are stranger still. One group, the crocodile icefish, has blood that is completely clear, with no red blood cells and no hemoglobin at all, the only vertebrates on Earth known to lack it entirely. In the frigid, oxygen-rich waters of the Antarctic, they manage to survive by absorbing oxygen directly into their clear, colorless blood. They are ghost fish, pale and translucent, living in a way no textbook would have predicted was possible. The waters and the ice hold other lives too, some of them formidable. There is a seal in those waters called the leopard seal, a sleek and powerful predator 10 feet long and weighing as much as a small car, with a serpentine head and a mouth full of teeth, that hunts penguins and other seals with a speed and ferocity that has made it one of the few animals in Antarctica that human beings genuinely fear. It lurks at the edge of the ice, waiting for penguins to enter the water, and takes them in an explosion of speed. And yet even the leopard seal has shown on occasion a puzzling gentleness toward people. There is a well-known account from a wildlife photographer who spent days in the water with a large female leopard seal, expecting aggression, only to have the seal begin, apparently, to try to feed him, bringing him live penguins and then dead ones, seemingly baffled that this strange, helpless creature would not eat, behaving toward him almost as if he were a hopeless pup she had decided to look after. No one fully knows what was happening in the animal's mind. It is another of those Antarctic moments where the neat categories break down, where a thing we thought we understood turns out to be stranger and more mysterious than we assumed. There is another seal, the Weddell seal, that lives farther south than any other mammal on Earth, spending the winter beneath the sea ice, keeping breathing holes open in the frozen ceiling above it by grinding away at the ice with its teeth, diving deep into the black water beneath the ice in search of fish, navigating a lightless world under a solid roof of frozen ocean. And in the sky and on the wing there are the seabirds, the great wandering albatross chief among them, a bird with the longest wingspan of any living creature, up to 11 feet from tip to tip, that soars for years at a time over the Southern Ocean, sleeping on the wing, circling the entire globe again and again on the endless westerly winds, coming to land only to breed, mating for life and living for decades, a creature so perfectly adapted to the wind that it can travel thousands of miles while barely beating its wings. The old sailors held the albatross in awe and believed it carried the souls of the dead. And to kill one was to invite a terrible curse, a superstition that Coleridge made immortal in his poem of the Ancient Mariner, and the burden of the slain bird hung about his neck. Watch a wandering albatross ride the wind above the great grey swells of the Southern Ocean, effortless, tireless, at home in the emptiest and most violent seas on earth. And the old superstition does not seem so foolish. There is something in the sight of it that touches the edge of the sacred, and far below all of this, on the floor of the Southern Ocean, in the cold and the perpetual dark beneath the ice, there is a world that scientists have only recently begun to glimpse, and it has surprised them again and again. When remotely operated submarines and dredges first brought back images and specimens from the Antarctic seabed, researchers expected a barren, impoverished place. What they found instead, in many areas, was an astonishing riot of life. Gardens of the deep as rich and strange as a tropical reef, but built of cold-loving creatures found nowhere else. Great forests of sponges, some of them thought to be among the oldest living animals on Earth, growing so slowly in the cold that a single specimen may have been alive for over 1,000 years, a creature that was already ancient when the first polar explorers were being born. Sea spiders grown to monstrous size, far larger than their relatives in warmer seas, a phenomenon called polar gigantism that scientists are still working to fully explain, in which the frigid, oxygen-rich water somehow allows certain creatures to grow to strange and enormous dimensions. Brittle stars and sea stars and feathery crinoids carpeting the bottom in their millions, worms and mollusks and creatures without common names. An entire ecosystem evolved in isolation over tens of millions of years, cut off from the rest of the world's oceans by the ring of cold current that surrounds the continent. Much of it has never been seen by human eyes, and new species are still being described with almost every expedition. There are, quite literally, whole forms of life at the bottom of the Antarctic Sea that no one has yet discovered, waiting in the cold and the dark, in one of the last great unexplored frontiers left on our planet. And beneath the floating ice shelves, in the black water of the hidden cavities where the ice meets the sea hundreds of miles from open water, explorers have found life where they expected none at all. When scientists drilled through a thick ice shelf and lowered a camera into the freezing water below, into a place with no sunlight, no obvious source of food, hundreds of miles from the open ocean, they expected to see nothing but bare rock and mud. Instead, clinging to a boulder in the dark, they found creatures, strange stationary animals living somehow in that impossible place, feeding on who knows what, carried in on the slow currents beneath the ice. No one had predicted they could be there. No one is entirely sure how they survive. It was one more reminder in a place full of them that life is more resourceful and more mysterious than our confident expectations, and that Antarctica, again and again, humbles those who think they know what it contains. Even on the barren rock and ice of the land itself, in the few places not permanently buried, life finds a foothold. There is a region called the Dry Valleys, near the coast, that is one of the strangest landscapes on the planet. These valleys are astonishingly free of ice and snow, kept bare by fierce dry winds that scour away any moisture, and they are so cold and so utterly arid that they are considered the closest thing on Earth to the surface of Mars. NASA has used them to test equipment bound for the Red Planet. It has not rained in some of these valleys for perhaps 2 million years, and yet even there life persists, not out in the open but hidden inside the rocks themselves. If you split open certain stones in the dry valleys, you will find, just beneath the surface, a thin green layer of living organisms, microbes that have retreated into the rock to shelter from the impossible conditions outside, eking out an existence in the last thin margin where survival is barely possible. Life does not give up easily. Even here, at the edge of what is possible, it holds on. And in the dry valleys there is one more thing, a sight so bizarre that when it was first described, some people refused to believe it. On the snout of one of the glaciers, a slow red stain seeps out of the white ice, spreading down the glacier's face like a wound, like blood pouring from the ice itself. They call it blood falls. For a long time no one could explain it. The answer, when it finally came, was almost as strange as the appearance. Beneath that glacier, lies a pocket of ancient trapped salt water, a brine so salty it cannot freeze, sealed away from the air for perhaps 2 million years. That water is rich in iron, and when it slowly leaks out at the glacier's edge and meets the air for the first time in eons, the iron rusts, staining the ice a deep, arterial red. And in that dark, sealed, oxygen-free brine, cut off from the world for 2 million years, scientists have found microbes living still, surviving on iron and sulfur, a tiny ecosystem sealed in ancient water, discovered only because it bleeds out onto the ice. The continent is full of these things, secrets that hide until some strange sign gives them away. And there is another kind of secret lying on the ice, one that comes not from the earth at all, but from the sky, and from far beyond it. Antarctica, it turns out, is the single best place on the entire planet to hunt for meteorites, for pieces of other worlds. This is not because more of them fall there than anywhere else. They fall evenly across the whole globe. It is because of a beautiful accident of the way the ice moves and the way the continent looks. When a meteorite falls onto the ice sheet, it is gradually buried by snow and swallowed into the slow-moving ice, and then, over thousands of years, the flowing ice carries it toward the coast. But in certain places, where the ice runs up against a buried mountain range and is forced upward, and where the fierce dry winds strip away the surface snow faster than it can accumulate, the ancient ice is worn back and its hidden cargo is exposed. In these special zones, called blue ice fields, for the deep color of the ancient compressed ice, meteorites that fell over tens of thousands of years across a huge area are concentrated and delivered up to the surface, laid out dark against the pale ice, waiting to be found. A dark stone on a plain of white ice can be nothing but a visitor from space, and so search teams walk and drive slowly across these fields, gathering them up. Tens of thousands of meteorites have been recovered from Antarctica, more than from all the rest of the world combined. And among them have been treasures beyond price. Rocks blasted off the surface of the moon by ancient impacts, which then wandered space for ages before falling to Earth. And rarest of all, pieces of Mars, hurled off the red planet by some colossal collision, drifting through the solar system for millions of years before landing on the Antarctic ice, where a human being one day picked them up. One such Martian meteorite found in the ice became briefly the most famous rock in the world, when scientists announced they had found structures inside it that might, just possibly, be the fossilized traces of ancient Martian microbes. The claim was fiercely debated and never confirmed, and most scientists today are skeptical, but the very fact that we could hold in our hands a piece of Mars, retrieved from the ice at the bottom of our own world, and argue about whether it carried the trace of alien life, tells you something about how strange and how valuable this frozen continent has become. It is a net cast across the sky, catching fragments of the solar system and holding them, preserved in the cold until we come to collect them. Now all of this, the ice cores and the hidden lakes and the buried mountains and the fantastical wildlife, is studied today by an international community of scientists who live and work on the continent through an arrangement that is, in itself, one of the more remarkable achievements in human history. Because Antarctica, alone among the continents, belongs to no one. It has no government, no permanent population, no native inhabitants, no economy in the ordinary sense. And this is not an accident. It is the result of a deliberate choice made at the height of the Cold War that stands as one of the rare occasions when the nations of the Earth chose cooperation over conflict. In the 1950s, as the Cold War hardened and the world divided into hostile camps, Antarctica presented a dangerous problem. 7 countries had made overlapping territorial claims to slices of the continent, some of them conflicting directly, and the 2 superpowers, the United States and the Soviet Union, recognized no claims at all, but reserved the right to make their own. It could easily have become another arena of confrontation, another place to plant flags and point weapons. But something unexpected happened instead. In 1957 and 58, scientists from around the world, including from both sides of the Iron Curtain, collaborated on a great cooperative scientific effort called the International Geophysical Year, and much of that effort focused on Antarctica. Scientists who were supposed to be enemies found themselves working side by side on the ice, sharing data, sharing hardships, and discovering that the pursuit of knowledge could cross the deepest political divides. Out of that spirit came something almost unheard of. In 1959, 12 nations, including the United States and the Soviet Union, at the very peak of their rivalry, signed the Antarctic Treaty. The treaty did something extraordinary. It set aside the entire continent, an area larger than Europe, as a place devoted to peace and science. It banned all military activity. It banned nuclear weapons and nuclear waste. It froze all territorial claims, setting them aside without resolving them, so that the argument over who owned what was simply suspended indefinitely in favor of open scientific cooperation. It guaranteed freedom of scientific investigation and the free exchange of results, and it allowed any nation to inspect any other nation's facilities at any time to ensure the rules were being followed. In the middle of the most dangerous standoff in human history, when the two great powers had weapons enough to end civilization, they agreed that at least one part of the Earth would be kept free of all of that, dedicated entirely to the peaceful pursuit of understanding. Later agreements went further still, banning mining and mineral extraction across the entire continent, protecting it as a natural reserve. The Antarctic Treaty has held for more than 60 years. It has survived the collapse of the Soviet Union, decades of global tension, and the temptation of the resources that surely lie beneath the ice. It stands today as proof rare and precious that human beings are capable of setting aside their conflicts for something larger than themselves. The station that sits directly at the geographic South Pole is perhaps the most extraordinary settlement on the planet, a place that would have seemed like pure science fiction to Scott and Amundsen, who reached that same spot on foot at the cost of terrible suffering and, in Scott's case, his life. Today there is a modern research base standing at the pole, raised up on stilts so that the endlessly drifting snow does not bury it, housing dozens of people in reasonable comfort through the brief summer and a small, hardy crew through the winter, when the temperature outside can fall past -70 and the sun does not rise for 6 months. The building has laboratories, a gymnasium, a greenhouse where fresh vegetables are coaxed from artificial light, a library, a place to gather and eat and be human together against the immensity of the dark outside. Every scrap of it, every bolt and beam and can of food, had to be flown in across thousands of miles of ice. The people who live there mark the passing of time by rituals invented for the purpose, and there is a tradition when the last flight of summer departs and the winter isolation begins, of watching a certain film together and of the small community drawing close for the long night ahead. It is one of the strangest and most moving facts about our species that we have chosen to place a permanent outpost at the exact bottom axis of our spinning world, in a spot that offers us nothing but cold and dark and difficulty, purely for the sake of knowing and of being there and of proving that we can. The largest of the Antarctic settlements, though, is a genuine small town. On the coast, the American research station of McMurdo swells in the summer to hold 1,000 or more people, with roads and vehicles and dormitories and workshops, a harbour when the ice breaks up enough for a ship to reach it, and even, in years past, a certain rough frontier culture all its own. It is the great gateway to the continent, the hub from which people and supplies are ferried out to the smaller, more remote camps scattered across the ice. And ringing the continent are dozens of other bases, Russian and Chinese, Argentine and Chilean, Indian and Japanese, and many more, each a small island of human warmth and purpose in the immensity of the ice, each pursuing its own slice of the great collective effort to understand this place. At one Argentine base, children have even been born, part of a deliberate effort decades ago to strengthen a national presence on the continent, so that there are now human beings who can say, truthfully, that they were born in Antarctica, on a continent with no indigenous people and no native population, the only place on Earth where every single human being is, in the end, a visitor from somewhere else. And in recent decades, a new kind of visitor has begun to arrive, one that would have astonished the early explorers most of all: tourists. Each summer now, tens of thousands of people pay considerable sums to board ships and sail south across the same violent passage that nearly killed Shackleton, to cruise along the peninsula, to step ashore among the penguin colonies, to stand, if only for an afternoon, on the ice at the bottom of the world. For most of them, it is the journey of a lifetime, a place they had dreamed of since childhood. and the sight of that white coastline rising out of the sea moves many of them to tears. But it raises difficult questions too, about how much human presence this fragile and pristine place can bear, about the fuel burned and the risk of introducing foreign life, and the simple pressure of feet on ground that has known almost none. The rules are strict. Visitors must clean every speck of soil from their boots, must keep their distance from the wildlife, must take nothing and leave nothing. And still the debate continues about whether a place kept pristine for the sake of science, and the planet should be open to those who simply wish to see it, and about what we owe to a wilderness that belongs, in the end, to no one and to everyone. And so today, on that vast and frozen continent, several thousand scientists and support staff from dozens of countries live and work through the brief summers, and a few hardy souls remain through the long, dark, isolated winters when no aircraft can reach them, and they are as cut off from the rest of humanity as astronauts on a space station, perhaps more so. They study the ice, the oceans, the wildlife, the atmosphere, the cosmos, and it is worth pausing on that last one, because Antarctica has turned out to be one of the finest windows on the universe that exists anywhere on Earth. The high polar plateau, thousands of feet above sea level, is one of the coldest, driest, stillest places on the planet, and that combination makes for extraordinarily clear and stable viewing of the night sky. During the polar winter, the sun does not rise for months, providing a continuous darkness that no other observatory on Earth can match. Telescopes at the South Pole itself peer out at the faint afterglow of the birth of the universe, the ancient light left over from the Big Bang. And deep in the ice, an even stranger instrument has been built. They call it Ice Cube, and it is a telescope unlike any other, for it does not look up. It looks down into the ice itself. Buried in the deep, ultra-clear ice beneath the South Pole, over a cubic kilometer of it, is a vast three-dimensional array of sensitive light detectors strung on cables lowered into holes melted deep into the ice sheet. The entire apparatus is designed to catch neutrinos, ghostly subatomic particles that stream through the universe in unimaginable numbers, produced in the most violent events in the cosmos, in exploding stars and the hearts of distant galaxies. Neutrinos are so faint and so reluctant to interact with ordinary matter that trillions of them are passing through your body every second, right now, without your ever knowing, and they pass straight through the entire Earth as if it were not there. To catch even a few of them, you need an enormous, perfectly transparent, perfectly dark medium in which to spot the tiny flash of light that occurs on the rare occasion one of them collides with an atom. The deep ice of Antarctica, ancient and crushed and glass-clear and utterly free of light, is one of the only places on Earth suitable for the task. And so at the bottom of the world, buried in ice that fell as snow before human history began, an instrument the size of a mountain listens for messengers from the most distant and violent corners of the cosmos. There is something almost poetic about it, that the emptiest, most remote place on our planet should be the one from which we reach furthest out into the universe, and the sky above that ice, during the long polar winter, offers a spectacle that people travel to the ends of the Earth to witness and still struggle to describe. The aurora australis, the southern lights, the mirror image of the more famous northern lights, unfolds across the Antarctic sky in curtains and ribbons of green and red and violet, silent, shifting, alive. It is caused by charged particles streaming out from the sun, caught by the Earth's magnetic field and funneled down toward the poles, where they collide with the gases of the upper atmosphere and set them glowing, oxygen burning green and red, nitrogen glowing blue and purple. But no explanation of the physics quite prepares a person for the sight of it. The men of the early expeditions, wintering over in their huts on the coast, wrote about it in tones close to reverence, describing how the whole sky would come alive, how the light would ripple and dance overhead as though drawn by some invisible hand, how it fell across the snow in colors that seemed to belong to no earthly thing. For the scientists who winter over today, when the sun has vanished for months and the isolation presses in, the aurora is one of the few great consolations, a reminder that even in the darkest and most remote place on Earth, the sky can still fill with unearthly light. And it connects the frozen continent to the sun itself, 93 million miles away, in a display that has been playing over the poles since long before there was anyone to watch it. To spend a winter in Antarctica is to enter a state of isolation that few human beings have ever known. When the last aircraft of the season lifts off before the darkness closes in, the small crews left behind at the research stations are, quite literally, beyond rescue. For the months of winter, no plane can land, no ship can reach them through the thickening sea ice, and if something goes wrong, if someone falls seriously ill or is badly injured, there is often nothing to be done but wait and hope, and rely on whatever medical skill happens to be present among the small group of people trapped together in the dark. There is a famous story of a doctor at a Soviet station in the 1960s who developed appendicitis in the depth of winter, with no way out, and no other physician within thousands of miles. He operated on himself. Lying on the operating table, using a local anesthetic and a mirror, directing two untrained assistants, he removed his own appendix, and he survived. It is the kind of thing that could only happen in a place like this, where the ordinary safety nets of civilization simply do not reach, where human beings are thrown back entirely on their own resources and their own will to live. The people who winter over speak of a particular psychology that sets in during the long night, a heightened intensity to relationships, a strange warping of time, a sense of the outside world becoming distant and almost unreal. Space agencies study them, because a winter in Antarctica is one of the closest analogues we have to the isolation of a long voyage into space, a rehearsal for the loneliness of a journey to Mars. There is another quality to the winter darkness that the wintering crews describe, harder to put into words, having to do with the sheer completeness of the silence. In the deep interior, on a windless day, the absence of sound is total in a way that people who have never experienced it find difficult to imagine. There are no birds, no insects, no rustling leaves, no distant traffic, no human voices but your own. The air itself is so cold and so dry and so still that it seems to swallow sound. People describe hearing their own heartbeat, the rush of their own blood, the faint crystalline hiss of their breath freezing in the air. It is a silence that can feel like a physical presence, vast and ancient and utterly indifferent, and it works on the mind in strange ways. Some find it unbearable. Others find in it something close to a religious experience, a stillness so profound that it seems to touch something at the very root of what it means to be alive and alone and aware in an enormous and silent universe. Now I want to return, before we finish, to the ice itself and to the future, because the story of Antarctica is not only a story of the past and the present, it is, increasingly, a story about what is to come, and it is a story with a great deal of uncertainty and no small amount of tension woven through it. For most of human history, the Antarctic ice sheet seemed like the very definition of permanence, a thing so vast and so ancient and so cold that it might as well have been eternal. But we now understand that it is not eternal, and that it is not entirely stable, and that some parts of it are changing in ways that could reshape the world. The concern centers on West Antarctica, and on one glacier in particular. Much of the West Antarctic ice sheet rests not on land above sea level, but on bedrock that lies below sea level, which means the ice is in contact with the ocean, and warm ocean water can reach in beneath it and melt it from below, out of sight, in a way that surface temperatures alone would never reveal. There is a glacier there called Thwaites, an enormous river of ice roughly the size of Florida or Great Britain, and it has earned a grim nickname among the scientists who study it. They call it the Doomsday Glacier. Thwaites is losing ice at an accelerating rate, and it acts as a kind of cork, holding back the much larger mass of ice behind it. If Thwaites were to collapse entirely, it would raise global sea levels by around 65 centimeters, more than 2 feet on its own, and its collapse could destabilize the ice behind it, ultimately contributing to a rise of several meters over the coming centuries. The waters that would displace are not abstract. They are the waters that lap at every coastal city on Earth. How fast this might happen, and whether it can be slowed or stopped, are among the most urgent questions in all of science, and they are genuinely difficult questions, because the processes involved happen far out of sight, beneath thousands of feet of ice and freezing water, in one of the most inaccessible places on the planet. In recent years, teams from several nations have mounted extraordinary expeditions to Thwaites, drilling through the ice, sending robotic submarines beneath the floating edge of the glacier to explore the hidden cavity where the warm ocean water meets the ice, gathering data from a place no human can go. What they have found is sobering. The warm water is reaching further beneath the glacier than anyone expected, and the ice is more vulnerable than earlier models suggested. But there is also a great deal that remains genuinely unknown, and honest scientists will tell you that they cannot yet say with confidence exactly how fast Thwaites will change or precisely how much time we have. The uncertainty itself is part of the story. This is a real mystery unfolding right now with real consequences, and the people trying to solve it are working at the very frontier of what human beings can observe and understand. And that, in a way, brings us back to where we began, to the men trapped in the ice more than a century ago, and to the question of why this continent keeps drawing us south. Because for all our satellites and submarines and instruments buried in the ice, Antarctica remains, in the deepest sense, a place of mystery. We have mapped its hidden mountains, but we do not fully understand how they formed. We have found lakes sealed for millions of years, but we do not yet know all of what lives in them. We have read the history of the climate in its ice, but we cannot yet say for certain what the ice will do next. We have built telescopes to see the birth of the universe from its surface, and we still cannot see clearly beneath one of its own glaciers. It is the most studied wilderness on Earth, and at the same time, one of the least understood. Every answer it gives up seems to open onto three new questions. There is a particular feeling that people who have spent time in Antarctica describe again and again in almost identical terms, whether they were there 100 years ago or last winter. It is a feeling of scale, of insignificance, but not a frightening insignificance. It is something closer to peace. Standing on that endless white plain, under that impossibly clear sky, in a silence so complete that you can hear the blood moving in your own ears, a person becomes aware, in a way that is difficult to achieve anywhere else, of how brief and small a human life is against the great slow processes of the earth. The ice beneath your feet fell as snow before the pyramids were built, before the first cities, before the first written word. It has been there, patient and indifferent, through the entire span of human history, and it will very likely be there long after all of it is forgotten. There is a strange comfort in that, to stand upon something so much older and larger than yourself, and to feel for a moment connected to a scale of time that dwarfs every worry and every ambition of an ordinary human day. Think for a moment about everything this single continent holds within it, all at once in the same frozen mass. It holds the deepest cold ever recorded on Earth, and a lake of open lava. It holds 90% of the world's ice, and the driest desert on the planet. It holds a green and forested past buried under a white and frozen present, jungles turned to fossils turned to stone. It holds lakes sealed away for 15 million years, and life still stubbornly clinging on inside them. It holds an archive of the Earth's climate stretching back nearly 1 million years, written in bubbles of ancient air. It holds pieces of the Moon and pieces of Mars, scattered on its blue ice. It holds a telescope buried in its depths that watches ghost particles fly in from the edge of the universe, and a sky that fills with unearthly colored light through the long polar night. It holds the graves of men who died for the sake of reaching an empty point on a map, and the descendants of the whales we nearly destroyed, returning at last to sing again in its waters. It holds the memory of one of the greatest survival stories ever told, and the promise of drowned coastlines yet to come. It holds a peace treaty that has outlasted the Cold War that produced it, a corner of the earth set aside, against all the odds, for knowledge instead of conquest. All of this in one place in the same great silence, at the bottom of the world. And still, when everything known about it is set down and accounted for, the largest part of what Antarctica is remains unknown. We have flown our radar back and forth across it and drawn the shape of the hidden land beneath, and still we cannot fully say how its buried mountains rose. We have drilled into its sealed lakes and found them full of life, and still we do not know the half of what lives there. We have read its ice like a book and learned the story of the planet's past, and still we cannot turn confidently to the next page and say what the ice will do in the century to come. It is a strange and humbling thing, in an age when we carry the sum of human knowledge in our pockets and map the surface of distant planets from our desks, to be reminded that there remains, on our own world, a place this large and this near that we still do not understand. Antarctica keeps that reminder alive. It keeps the old essential human feeling alive, the one that sent Cook south into the ice and Shackleton across the impossible sea, the feeling that there is something out there past the edge of the known, something worth suffering to reach, something that will not give up its secrets without a struggle. The men of the Endurance felt it. The scientists drilling for million-year-old ice feel it. It is perhaps the deepest reason we keep going back, past all the suffering and the danger and the cost, to a place that offers us so little and asks of us so much. We go because it reminds us of something we too easily forget, in the warmth and noise of our ordinary lives. That the world is vast and old and full of wonders we have barely begun to understand. That there are still true blanks on the map, true mysteries left to solve. That the Earth is stranger and more magnificent than anything we could have invented. Antarctica does not care about us. It never has. It goes on in its immense white silence, keeping its secrets, giving them up one at a time, slowly, to those patient and brave enough to come and ask. And long after the last of us has gone, when everything we have built has crumbled into dust and been forgotten, the ice will still be there, at the bottom of the world, glittering under the same cold stars, holding the memory of a planet in its frozen heart, waiting as it has always waited, in silence, in darkness, in peace.